Okay, sorry, I ran out of time on my video length recording, so we're gonna pick it up with a second video, but it should be pretty short. So I got the course laid out, got the sides on. Clearly, it's a side, side, side. The questions are, what are the bearings for the last two legs of the race? Whenever I'm asked to do a bearing on a triangle sketch, I will always pull in a crosshair, north, south, east, west, and place it at the spots that I'm trying to work on, because I need to know how to draw my angles correctly. So make sure you get a habit of, if you find a bearing, place a north, south, east, west right on the spot. So this is more of an angle reasoning problem. As you look at it, the angles that I need, which are bearings, are going to be this one right here and this one right here. So the bearing from B to C and C to A. So a north, let's cover these up. I didn't mean to show you guys this yet, but a north bearing east and a south bearing east. The thing about the bearings is the first one's not inside the triangle, and the second one, even although it is inside the triangle, is not an entire angle. Now the first one I think actually isn't that difficult to figure out. What we're going to do is calculate angle B. Law of cosines calculation. So you also, I'm going to subtract 1100 because that's the side across from B. So I just set that formula up, inverse cosine of that expression on my calculator, get an answer. Turns out that one comes out to be 25 degrees. Now, if B is 25 and I want that bearing, that red angle right next door, I know between north and east is 90 degrees. So it's pretty simple, just subtract from 90 and say, well, now I've got 65 degrees. So that one's not too bad because you have basically a pair of complementary angles and you can find one law of cosines, find the other, subtract from 90. So there's my north 65 east. The other one, there's different things I can do with this. I guess I got to think about what angles I know that correspond to the angle I'm trying to figure out. 65, actually, that is an angle. If you think about it, it's related. There's some ideas here about north-south lines that you guys should hopefully know, and that's a north-south pair of lines is parallel. And so if you have parallel lines, north-south, little geometry review here, cut by a transversal, then alternate interior angles are congruent. Remember that idea from geometry? So what that means is I actually know that 65. Now that's a connection you guys will have to make. There is, with a bearing problem like this or problems like this one, very often you're going to use the concept of north-south being parallel or east-west being parallel. That causes alternate interior angles that are congruent. Okay, so again, one more time. If I know this is 65, then I know this is 65. Alternate interior. Well, that's partial. That's part of the big angle. Well, now if I do angle C, law of cosines, I should be able to subtract 65 from that, get my answer. So law of cosines, find angle C, subtract 65. Pretty straightforward way to do it. Okay, the only other option I can see on this one is that you could have dropped this south line down, and maybe some of you guys are thinking about that, and created a right triangle. If you didn't see the alternate interior idea, but you've got 25, 90, you could have got 65 that way. So there's another way to go. Definitely would work. Okay, last one. Sorry, I think I said this was the last one, but there is one more, and then we'll wrap it up, which is a side, side, side formula for area. Pretty simple problem. They're all pretty simple as far as formulas go. It's always going to be the initial understanding, the setup, the sketches, that kind of stuff. But it's a formula that allows you to find area where you don't know the height of a triangle. We had one of these earlier in the chapter. So you need to do basically kind of one side step calculation, which is figure out what the S number is. S is the sum of the three sides. Once you have that, you can go to the formula. So here we have an island with dimensions 800, 300, and 700. So you've got an S that would be 1/2 of 1800. So your S value is 900. Go into the area. And it goes S and then S minus each of the sides. So 900 minus 800. 900 minus 300 and 900 minus 700. Then this one has a price attached to it per square foot, so then you multiply by 10 to get your actual dollar amount. So just a way of finding an area, we've got a couple of those, and it's nice sometimes when you don't have the height to have an alternative, and this is an alternative to finding an area. Okay, well that does it for the notes for law of cosines. Just to let you guys know, there are worked out keys for the law of sines, law of cosines problems on Moodle for some of the word problems. So if you're struggling, you can kind of check that out. Otherwise, on Monday, we'll take questions on both law of sines, law of cosines, clean it all up, and then start reviewing for the test.